Ma'am, it is audible, ma'am. Gomati, ma'am. Gomati, ma'am. Whether it is voice is audible for everyone. Gomati, ma'am. Voice is audible for everyone. Ma'am, Gomati, ma'am, your voice is not audible, ma'am.
கீர்த்தனா, நான் பேசுறது உங்களுக்கு கேட்கவே மாட்டேங்குது. ஹெட்போன் தான் போட்டிருக்கேன். கேட்கல உங்களுக்கு. அவங்க பேசுறது எனக்கு கேக்குது, நான் பேசுறது உங்களுக்கு கேட்க மாட்டேங்குது. நித்யா மேம் பேசுறது ஓகேவா? Ma'am, can you hear me?
Yes, madam.
Hello, ma'am. Ma'am, can you hear me? Hello, ma'am. Ma'am, can you hear me? Hello. சவுண்ட் கம்மியா இருக்கு. இப்பதான் இருக்கு. இப்பதான் நான் ஏதோ செக் பண்ணி தெரிஞ்சது.
Connected on your chat.
Can you hear me?
மேடம் கேக்குதுங்க மேடம்.
Ma'am, hello.
மேடம் கேக்குதுங்க.
Audible, ma'am.
Okay, ma'am. Okay. Okay, ma'am. Thank you. Okay, good morning to all. Okay, everyone, in the last session, you have learned about what is machine learning and types of machine learning, that is supervised learning and unsupervised learning. And now we are going to say about the applications of supervised learning, that is or the types of supervised learning, that is a classification and what are the machine classification model. Then what is ROC and how we can identify the ROC under the code AMT, and what is bootstrapping, then class validation, then percept one. So in the morning session, we will discuss these things. Then afternoon session, we will move on the neural networks. So already you know that what is the supervised learning? It is a type of learns from everyday data set in our class. We can get that input output from that we can get the output in class. Already you know evaluation and user by detecting expanding. Already you know the direction and what are the algorithms the session in the module predict language. These are the different classification the regression. In regression, for both we can use regression. We can identify the values in a confused manner. In a classification, identify values based on categories. So next one, yeah. So used in the classifications. So what are the used in? Next one is F1 score. Finally, from that we can use on table, that is a confusion matrix. Then last one, ROC curve. So first one, accuracy. Accuracy is mainly used to measure the percentage of correct predictions based on this based on the model. What we have what we get model in our hand. Based on that, we can calculate the percentage of correct predictions. So accuracy is calculated like it is proportional to true positives plus true negatives divided by true positive plus true negative plus false positive plus false positive. So before that, we should know what is true positive and true negative. So these terms are using confusion matrix. So what is a true positive? True positive is the model is mainly used to predict the positive values. Next one, true negative. So this model correctly predict the negative values or a negative class. Next one is the false positive. So this model is used to incorrectly predict the positive values. So the values will be positive, but we can predict the incorrect values. Next one is the false negative. So false negative, so this is the model used to predict the negative values, negative class or negative values. So these are the terms which can be used to calculate the performance measures like accuracy, recall, like that. So true positive, true negative, false positive, false negative. So these are the important terms which is used in the measurements. So first one is the accuracy. So accuracy is mainly used to predict the correct instance or correct values from the total instances or a total value. So the formula is true positive plus true negative divided by true positive, true negative plus false negative plus false positive. So next one is the precision and recall. So precision is calculated as it is proportional to true positive divided by true positive plus false positive. That is mainly used how many of the positive predictions made by the model. Is mainly used in this scenarios where the positives are costly, where the positive
For this information, I have informed Komati ma'am connecting for the 5 to 10 minutes.
Can you hear me? Hello, ma'am.
Yes, ma'am.
Okay, ma'am. Ma'am, is it audible now?
Yes, ma'am.
Okay, ma'am. So this is the example of a confusion matrix. So here we can consider, we can take the parameters like a true positive, true negative, false positive, and a false negative for the confusion matrix. So in this diagram, we can get the true positive values as 3 and the true negative values as 3 because we have the actual values, actual animal, and the predicted animal value will be the same. So that will be two positives. And the true negative value also 3. So kindly consider another one example of confusion matrix. Here we have a actual animal have 2, so that the true positive, the value of true positive is 2. And the actually not animal cases as 2, so that the true negative value is 2. Next one is the false positive. In that we have an actual not animal cases as 1, so that the value of positive, false positive is 1, and the false negative is 1. Consider the model 1. In this, we have a calculate the, from that confusion matrix, we can calculate performance matrices, accuracy, precision, and the recall, then F1 score. Here, true positive value is 3 and the false positive value is 3. So that the accuracy is 50%, and the precision also 50%. The recall value is 100%. F1 score, the value of F1 score is 67%. Here, the F1 score is calculated based on the precision and the recall, so that we have some value in that precision and recall, so that the average of value may become in the F1 score. Next one, model 2. Here, we have the true negative values 3 and the false negative values 3, so that the precision value is 100%. Here the recall value of the recall is 0%, so that F1 score automatically will give the value 0% only. Here, because F1 score is based on the two terms, that is a precision and a recall. Next, model 3. In that model 3, here we have a true positives, true negative, and a false negative, so that the precision value will be 100%. We can get the recall value also 67%, so that F1 score will get some values. They show some values. Next, model 4. Next one is the receiver operating characteristics, that is the ROC curve. So it is a curve that is mainly used for graphical representation. It is a graphical representation mainly used to evaluate the performance of a binary classification model. Not only a binary classification model, we can use it for a multi-classification also. The ROC curve, so receiver operating characteristic, it is nothing but it is a ROC curve. Simply we can tell it as a ROC curve. The ROC curve plot the positive rate against the false positive rate. That is a positive rate. That means we can, positive rate means is a recall only, true positive rate. So it mainly focus on true positive rate and also the false positive rate. So true positive rate, also known as the sensitivity or recall. Next one is the false positive rate. So in the ROC curve, it plots the true positive rate on the y-axis, and the false positive rate will be drawn in the x-axis. So we can call it as the main components of a ROC curve. So components of ROC curve is nothing but a true positive rate and a true negative rate. Sorry, false positive rate. So mainly it is used to access the performance of machine learning algorithm and select the optimal models. Mainly where it is, how it is used. Next one is the where we can use it. It is used in a variety of field like medical diagnostic, radiology, etc. So in this curve, so how we can create the curve? So the ROC curve is created by calculating the TPR value and the FPR value, that is true positive rate and a false positive rate at every possible threshold, and then graphing TPR over FPR. So we have to consider many threshold values when we are draw the ROC curve. So what is the perfect model here? Each point on the curve represents different threshold. Already that here the diagonal line should be drawn from 0 to 0 to 1 to 1. Okay, this is the diagonal line. It represents a model with no discriminative power. That will be called as random guessing. It is a model. See here. So we can draw the ROC curve from 0.0 to 0,0 to 1 to 1. So that will be called as the that is we can consider it as a no discriminative power. That is random guessing. So here the red color lines shows that so the red color line shows that random classifier, and the here the value 1.0 will be called as perfect classifier. So we should note that a perfect ROC model is represented by the point at 0, 1 on the ROC curve. So that will be called as the perfect classifier. So next one is the before we go for a ROC, we should know what is a true positive rate and what is a false positive rate. So here the true positive rate, that is also known as sensitivity or recall. It measures the proportion of actual positives correctly identify the model. So true positive rate means actual positives. That's all. Actual positives. We can keep in mind that actual positive will be called as true positive rate. We can calculate by using the formula, that is a true positive divided by two positives plus false negatives. So by using this formula, we can calculate true positive rate. So next one, false positive rate. So this will be the proportion of actual negatives. This is the actual positives. So here the false positive rate will be the actual negatives. Just you can keep in mind actual negatives. By using actual negatives, we can calculate the false positive rate. So this measures the proportion of actual negatives incorrectly identified as positives by the model. So it is calculated as false positives divided by false negative plus true negatives. So this is the formula used for calculating false positive rate. So here the 0.1. So this is the important point used in the ROC curve. So 0, 1 point is also called as perfect classification. Here ROC curve will be drawn from the coordinates of 0, 0 to 1, 1. That's all. This 0, 1 point is very important in the ROC curve. So that is called perfect classification. So here the random guess would give a point along the diagonal line from the bottom left to the top right corners. Here this is the random guess. That is the random classifier. So this is the classifier. So this will be the red color line will be called as the random classifier or a random guess. So this is the diagonal line from the bottom left to right top corners. So points above the diagonal represents the good classification result. That is better than the random value. And the line below the random classifier represents the bad result. So this is the overview of the ROC. That is a receiver operating characteristics. So what are the important points we should remind in our mind means, so the coordinates value is 0, 0 to 1, 1, and also the value 0, 1 point. That is called as perfect classifier. Next one is the red color line. That is the diagonal line. So the diagonal line is very, very important because it is used as a to predict the result. So this is the diagonal line that is known as the random guess or random classifier. Next, the points, the lines The lines above the random classifier represents the good classification result. The line below the diagonal line will be represented as bad results, bad classification result. Here, consider one example. We can calculate. We can draw the ROC curve based on the result. Here, true positives, false negative, false positive, and true negative values given here. The true positive, the value of true positive is 63. Value of false negative is 37. False positive value is 28, and the true negative value is 72. By using this value, we can calculate true positive rate like this. So we have to remember the formula, and we have to recall the formula, that is TPR, true positive rate. The true positive rate will be calculated as true positive, that is the proportional to true positive divided by true positive plus false negative. That is, it is mainly based on the actual positive values. So we have to apply these values into the formula. We will get the answer as 0.63. Next one is false positive rate. So the false positive rate will be calculated by using this formula, and we will get the value as 0.28. So the true positive rate will be taken as y-axis, and the false positive rate will be taken as x-axis. So now we have to draw the curve. We will get like this. That means the result will be over the random classifier, so that it shows that we will get a good result. So next consider another example. Here value of for the terms positive, false negative, false positive, true negative. So we apply the values into the formula. We will get true positive rate as 0.77 and a false positive rate also 0.77. So that the ROC curve will be overlaid on random guess, that is random classifier here, which means the model is equally likely to correctly identify a positive case. It is as it is to incorrectly identify a negative case as positive. So this model or this values suggest that the model's performance is not very good as a good. We cannot tell it is not very good or it is good, because it is equally likely to correctly identify a positive case. So this model have a high TPR and a low FPR. So we can consider it is not a good. Already we know that the curve should be present above the random classifier. So only we can consider good one. So here already we have seen that in example 1 and also example 3 also shows the same result. See here In this example, the values are given and the true positive rate or sensitivity or recall. So that this true positive rate will be calculated based on recall, and also it is known as sensitivity or recall. In this TPR, the value of the TPR is 0.24 and the false positive rate is 0.88. So that the curve is drawn under the random classifier, so that we can conclude that it is not a good result. So it indicates that it will be a poor performance. So from this, we can, from these examples, what we can identify that the true positive rate should be greater than false positive rate. That means when the actual predictions should be higher than the false prediction. So only we will get a good result. Next one, area under the curve. So area under the curve is a single scalar value that summarizes the performance of a binary classifier. So before doing that, we can use the ROC curve for a binary classifier. Not only for a binary classifier, we can use multi-class classifier. We can use a ROC curve. AUZ is a area under the curve. It quantifies the overall performance or summarizes the overall performance of the model. So it ranges from 0 to 1, with the higher value that indicating a better performance. If the value of AUC is 1, it is a perfect model with a ideal separation of the classes. Next, the value of AUC is 0.5. The model performs more better than random guessing. So we can conclude the AUC value should be 1. So it is a metric. We can define it as a metric used to evaluate the performance of the binary classification model. And also it is derived from the receiver operating characteristic curve, which plots the true positive rate against the false positive rate at various threshold settings. So that if we want to draw the area AUC curve, we should know about what is false positive, false negative, true positive, true negative. Then how to calculate accuracy, precision, recall, and then F1 score. So these things we should know, very, very important. After that, by using these measurements, we can draw the ROC curve. From that ROC curve, we can draw the area under the curve. That is AUC. Here, the key points of AUC is AUC value range from 0 to 1. The range, that is the values from 0 to 1. The AUC is 1, the perfect model performance. It separates the classes completely without any overlapping. If that means it is a perfect classifier. We can say that AUC value is 1. It is a perfect classifier. The model distinguishes perfectly between the positive and the negative cases. If the value is between 0.5 to 1 means it is a good classifier. So we can divide the values as 4. There is 4 types. That is value is 1 and the 0.5 to in between 0.5 to 1, and if it is equal to 0.5, and if it is less than 0.5. So if it is the value is 1, it's a perfect classifier. Next, the value is between 0.5 to 1. It is a good classifier. That means the model performs better than random guessing. Next one is the value of AUZ equal to 0.5. That will be a random guessing or a random classifier. That means this model has no discriminative power, and it is a effective. It is as effective as random guessing. Next one, the value of AUZ is 0.5. We can say it as a worst. The result will be, already we know that it is a worst case. So worst than the random guessing, which may indicate that it is predicting the opposite of what we need. Okay, it will give the answer, or it will predict the answer what opposite to what we are expecting. Or we can say it as the model predictions are inversely proportional to the actual outcomes. Next one is the if we can imagine a model, we can imagine one model that is to detect whether a patient has a disease or not. So if the value of the AUC is 0.9, it means the model is very good. We can consider one scenario, that is the model designed to detect whether a patient has a disease or not. The AUZ, if the AUZ value is 0.9, it means the model is very good at distinguish patients with the disease from those without. It will correctly rank a patient with the disease higher than a patient without the disease, 90% of time. And next, consider next scenario. If the AUC is 0.6, the model is not very reliable by distinguish between the patients with and without the disease, with only 60% chance of ranking a diseased patient higher than a non-diseased one. So finally, we can conclude that the AUC provides a single threshold independent measure of a model's ability, and it is mainly used to distinguish between the classes. So it can be used to compare models and select the one with the best ranking ability, especially when dealing with the imbalanced data set. It is if we have a data set as an imbalanced one, from that we have to select the best ranking ability, so we can go for these AUZ curve to identify the ranks. Next one. Next one is the bootstrapping. So bootstrapping, so we have to recall what we have discussed. So here we have discussed what is supervised learning. So what are the types of supervised learning? One is the classification and another one is the regression. So classification is mainly used to categorize or classify the model. Next one is the regression. So regression already you have studied in a module 2. Next, what are the performance measurements or performance threshold or available in a classification model? So in a classification model, we have to calculate accuracy, precision, recall, F1 score under the confusion matrix. Next, ROC, next AUC. So these are the important measures which is used in a classification model. So before going to that, we should know what is a true positive and what is a true negative, and what is a false positive and what is a false negative. These things should be known that. Next one is the bootstrapping. So bootstrapping in the machine learning, it refers to the statistical technique used to improve model performance. It is mainly used to estimate the accuracy of the model by generating multiple datasets replacements. And also, this means the data points are randomly selected from the original dataset. So we can have a multiple datasets. From that, we can select data points in a random manner. Some points may appear multiple times in a original data set. So to avoid multiple data sets, multiple items, we can use a bootstrapping model. Excuse me. So from the original data set, when data sometimes will be repeated, means we can omit that multiple times of data. We can go for a bootstrapping, while others may not appear at all. So this result in multiple versions of the original data set. So it is mainly used to train multiple models on this different sampled data set. So we can reduce model variance, making the final model. It gives more robust and less prone to overfitting. Bootstrapping is also used for model validation. So main concept of bootstrapping, a data set is sampled multiple times with replacement. So this is the main concept behind in a bootstrapping. From that, we can resample with the replacement from the observed data. It is mainly used in statistics and machine learning to measure the accuracy of the model and to estimate the uncertainties. Here, we have to note down an important concept, that is out of back error. So it is an important concept that refers to the data points not selected in the bootstrap sample that can be used to estimate the model's performance without needing a separate validation data set. So the bootstrapping, so how the bootstrapping works, we have to concentrate three important concepts in a bootstrapping, that is resampling. Next one is the repeat sampling and the aggregation of result. So resampling will be the from the data set with the n observations. The bootstrap sample is created by randomly selecting n observations from the data set with replacement. This means the observations might appear multiple times while others might not appear at all in the given sample. Can you understand? So this is the resampling with replacement. We have n observations so that it is created randomly selecting n observations from the given data set with the replacement. So this means some observations may appear multiple times while others might not appear at all the given sample. So this is the resampling with replacement. Next one is the repeat sampling. So repeat sampling is important. It is the process. The resampling process is repeated many times. So that is the repeat sampling. So it producing a large number of bootstrap samples. Here, each sample is used to calculate a desired statistics like mean, median, variance. So this is the concept behind in the repeat sampling. Can you understand? So repeat sampling. First one is the resampling with replacement. Next one is the repeat sampling. Repeat sampling means the resampling process is repeated many times so that it produces a large number of bootstrap samples. So that here each sample is used to calculate a desired statistics like a variance, median, or a mean. Final one, aggregation. Aggregation. That means the distribution of the calculated statistics overall bootstrap samples is analyzed to estimate the sampling distribution of the statistics. So from this distribution, we can estimate a confidence intervals, calculate the variance, and get an idea of accuracy and reliability of the statistics. So these are the, in this way only bootstrapping works. Next, what are all the applications of bootstrapping? So what are the, so consider one scenario for bootstrapping. Suppose we have a data set of 100 observations and want to estimate the mean and its confidence interval. We create 1,000 bootstrap samples, each of size 100, by sampling with the replacement from the original data set. And then we can calculate the mean of each bootstrap sample. From the distribution of means across these 1,000 samples, we can derive an estimate for the mean and the confidence interval. So this is the best example of bootstrapping. So consider we have the data set of 100 observations. Now we have to estimate the mean and the confidence interval. Mean value and the interval value we have to calculate. We create 1,000 bootstrap samples. That means by using resampling with replacement, we can create 1,000 bootstrap samples, each of size 100, by sampling with a replacement from the original data set. Okay, then we can calculate the mean of each bootstrap sample. From the distribution of means across 1,000 samples, we can calculate or we can derive a mean and the confidence interval. So next, what are the advantages of bootstrapping? It is mainly used for improving the accuracy level, and we can use the data set in an efficient manner. So improve accuracy, that is, it can reduce overfitting and improve generalization. To improve the accuracy, it use the decision tree algorithm. Next one, efficient use of data. That means the data set will be used efficiently, because since the data set is sampled with the replacement, each model gets to learn from most of the data while still having some variation across the models. And also we can estimate the uncertainty with the help of bootstrapping. It helps to estimate the variability of the model predictions by repeatedly resampling and testing the model on different subset of data, because we have to use the concept of resampling with replacement and also repeat sampling. So by the method of repeat sampling, we can easily estimate the uncertainty value. So next one, what are the limitations of bootstrapping? Computationally intensive, that is, the bootstrapping involves creating many samples and calculating statistics for each, which can be resource intensive for large data set. Can you understand? So it is a computational intensive. That means it involves creating many samples by the concept of resampling and the calculating statistics for each data set, so that the data set can be resource intensive. Next one is the potential for overfitting. That means if the original data set is not representative of the population, bootstrapping will replicate any bias in the data set. If not managed properly, the bootstrapping can still lead to overfitting, and also it helps reduce the risk in many cases. Next one, applications. What are the applications where it is supported? The bootstrapping, which and where can use it? Confidence intervals under model validation or model evaluation, and also ensemble methods, random forest, bias and variance estimations, and also estimating the confidence intervals. So these are some applications of bootstrapping. Random forest, we can use it. Uses bootstrapped data set to train each tree in the forest. Confidence intervals. Bootstrapping is mainly used to estimate confidence intervals for model performance metrics like accuracy, precision, recall, and other statistics derived from the data set. So it is mainly to estimate the confidence intervals, because without by using the bootstrapping, the main support of the confidence intervals are bootstrapping methodology. Next one is the model evaluation. That means when data set size is limited, bootstrapping can provide an alternative to across validation by creating multiple bootstrap samples and training a model on each sample so that we can evaluate its performance across all the samples. Next one, ensemble methods. So these are the another application. So the bootstrap techniques is the foundation for bagging. So bagging for one of the main concept, bagging. So in that for that concept, it is the main pillar. Bootstrap work as the main pillar. It is an ensemble method where multiple models are trained on different bootstrap samples of the training data. Next concept is, so what we have discussed in this previous few seconds means there is a bootstrapping. So it is a machine learning technique that refers to the statistical in a machine learning. It refers to the statistical technique used to improve the model performance by applying resampling with replacement methodology and repeat sampling and aggregation of results. So these are the methodology used in bootstrapping to improve the to get the statistical to improve the model performance. So these are the statistical technique: resampling with replacement, repeat sampling, aggregation of result. So these are the techniques which is used to improve model performance. And also main concept is bootstrapping is also used for model validation. Model validation, for the model validation also, bootstrapping is a very, very important one. So model validation means when a data size is limited, bootstrapping can provide an alternative to cross validation by creating multiple bootstrap samples. So the dataset size is very, very limited. So that if we want to increase the size of the data set, so we can use the bootstrapping by so the dataset size is limited. We can use an alternative to increase the size of the data set, that is a bootstrapping. So by creating multiple bootstrap samples and training a model on each sample and then evaluating its performance across all the samples. So all the things that will be happened in the bootstrapping to increase the size of the data set. So we have discussed what is the main advantage of bootstrapping and disadvantages and where it is mainly used. That is a random forest, estimating confidence, mainly used the concept of confidence intervals and the model evaluation and the model validation. So these are in this field, the bootstrapping concept has been used. Next one is the cross validation. Cross validation is a statistical technique used in a machine learning model to assess the performance and the generalizability of the model. So it is we can say it as a robust technique used in machine learning model to assess the generalization ability of the model. And also it is mainly used or it helps in understanding how well a model is likely to perform on an unseen data set in detecting overfitting. So mainly it is used in an unseen data set. So it is a statistical technique or robust technique used in a machine learning to assess the generalization ability of the model or a performance. It is mainly to assess the performance as well as the generalization of a model. The goal of the main goal, the cross validation goal is to ensure that machine learning model performs well not just on a data it was trained on, but also on unseen data. Already told that it is mainly it is mainly focused on unseen data, that is test data. This helps in detecting overfitting and also ensure that the model performance is stable across different data set. So from different data set, it is mainly used to ensure the model performance. It is a good or a average or a below average or a low. So what is the performance of the model that is that can be easily identified by using the cross validation. Data partitioning. So data partitioning. So this is the important mechanism which is used in the cross validation. So it is used to split the available data set into multiple data set or folders. Okay, data partitioning means it is mainly used for splitting the whole data set into multiple subsets. The model is trained on some of these subset and it is tested on the remaining subset. So this process is repeated several times uh, for testing and the others for training. Can you understand? So this process will be repeated several times to get the performance of a model. So in the data partitioning, we have to take one model or a one data set. So that data set will be divided into multiple subsets. So in this, we won't do that. All divided data sets will be go for a testing, or all the subset of subsets will not go for a training. We have to split. Some data sets will be taken for testing, and the remaining subsets will be go for a training. So that from that result, we will get the performance of the model. So this process will be repeated again and again. The model is, so this process is repeated several times up to get a performance, good performance. That is the cross validation. Next one is the training and testing. In each iteration, some subsets will be trained on a specific portion of the data, and it will be evaluated on a different portion. By doing this repeatedly, already we know that what is happening in the data partitioning, that will be discussed in the training and testing modules. So the model is trained on a specific portion of the data and it is evaluated on a different portion. By doing this methodology repeatedly, the model gets tested on all parts of the data, which helps to ensure that the model is robust and not overfitting to one specific subset of the data. So if we repeatedly do this training and testing in a different portions, we can ensure that the model is robust and not overfitting. So performance matrices. After each subset, the performance of the model can be measured by using some evaluation metrics like accuracy, precision, recall, FN score, and RMSE. We have used some more evaluation metrics we will discuss in later. The results from all the polls are then averaged to provide a more reliable estimate of the model's general performance. So next, we can see what are the, so we have seen that what is cross validation and where it is, how it is used to identify the model's performance model. Next, we can discuss about the, we will see about types of cross validation to identify the performance of a model. So what are the types of cross validations? First one is the k-fold cross validation. Second one is the stratified k-fold cross validation. Next one is the leave one out cross validation, that will be called as elbow CV. Next one, leave P out cross validation. Final one, hold out cross validation. So here, most commonly in these 5 types, we can concentrate the k-fold cross validation because this one is the famous and repeatedly used by the users to evaluate the performance of the matrix. So first one is the k-fold cross validation. So this in this the data set is randomly. So we have to, before going for types, we have to discuss the what are the benefits and so what is the main benefit of cross validation means reduce overfitting, and it is a more reliable performance estimate and efficient use of the data set. That means reduces overfitting. So by training and testing the model on different subsets of the data, cross validation helps reduce the likelihood that the model will perform well on training data, but poorly on the unseen data. So it is mainly used for unseen data also, but it will perform well on a training data, so that it reduces through this, it reduces the overfitting. Next, efficient use of data. So this is also one of the benefit of cross validation. So this is the technique like k-fold cross validation. All data points are used for both training and testing, ensuring the entire data set is used. So in this efficient use of data means in k-fold cross validation, we are going to use all the data points for testing and training, so that we can use the data in a perfect manner. So next one is the limitation. So here we are using the cross validation. The expensive is very high, and also the bias is translated. So we cannot test or train the data if the data set is very small, that means the bias in small data set. The bias will happen in the small data set. When the data set is very small, we cannot apply the training and the testing in a proper manner. So what are the applications? So the cross validation is widely used in model selection, performance evaluation, and tuning hyperparameters. So model selection to compare. So what is model selection? To compare the performance of different algorithms or hyperparameter settings. To compare the performance of the algorithms, that is a model selection. Next one is the performance evaluation. So this will be assisted to generalize to an independent data set. Okay, that means independent data set will be generalized for a performance evaluation. Next one is the tuning hyperparameters. Cross validation is often used when tuning model hyperparameters to avoid overfitting the model to a particular data set. So these are some applications of a cross validation. Next one is the we have seen already what are the types of cross validation. From this, we have to concentrate k-fold cross validation and where it is used, what are the main things happening there. So we will discuss now itself about the k-fold cross validation. So in this, the data set is randomly split into equal size subsets. Already we know that subsets will be called as a fold. In this case, set to 5 or 10. So, k equals size subsets. So we have a data set. We have a data set, so that will be splitted into equal size of data set. So here the k is the size of the data set. Subsets of the size will be mentioned as k. So k is set to values like 5 or 10, but it can be any number depending on the dataset size. In each iteration, the model is trained on k minus 1 folds and tested on the remaining fold. Can you understand? So in each iteration, so here we have the 5 dataset means 5 subsets means first iteration the model is trained in each iteration. In the first iteration I have trained 5 fold. Next iteration I am going to train 4 fold only. Okay, that is the formula behind here. The model is trained on k minus 1 fold and tested on the remaining 1 fold. So this process will be repeated at k times. So each time using different fold as the test data. Because yes, it is absolutely correct. Because in the first iteration we are going to take 10 data set means 10 fold means in the second iteration we are going to train k minus 1 fold. That means 9 fold only we are going to take a training for the second iteration. So that so it will be repeated up to k times. So the final performance metric is the average of the k set score. So what are the steps behind here? Means first we have to split the data set. K-fold cross validation. We have a multiple types of cross validation, but K-fold cross validation is a very important and most commonly used method of the cross validation. So in this, first we have to split the data and we have to test and train the data. Then this process will be repeated again and again. From that we can calculate average performance. So we have to first step is the first step on split the data set. Here the data is randomly split into k equal sized subsets that will be called as fold. So this is the first step. Next one is the training and the testing. For each fold, the model is trained on k minus 1 fold. Okay, that is because uh, we have to repeat this task up to k times. So the model is tested on the remaining fold. Next one, so third step is the repetition. That means the process is repeated k times, each time with a different fold being used as the test set, and the remaining fold are used for training. If we have in the first iteration, totally we are going to take 5 subsets, so that we are going to test 5 subsets in the first iteration. In the second iteration, we are going to take 4 fold for testing, and the remaining 1 fold will go for a training. So this will be repeated. This will be happening again and again up to the end of the subsets. So finally, we will get the average performance. The result from each fold are averaged to provide the final performance metrics. So consider one example. In 5-fold cross validation, the data set is split into 5 parts. The model is trained and tested 5 times. So each time using 4-fold for training and 1-fold for testing. So the final performance is the average of these 5 tests. We consider another example. If you have 100 data points and the value of k, that is the size of the data set is 5, that is data set will be divided into 5 parts. The model will be trained on 80 data points. That means 5 minus 1 fold in the first iteration, because we have divided 100 data points into 5 fold. In the first iteration, we have to test the 100 data points. In the second iteration, we are going to train 80 data points, and 80 data points for testing, and the remaining for training, and the remaining 20 data points will go for a test. So this process will be repeated 5 times, and the average of 5 test result is reported. So from this report, we can calculate the average performance. That means we will get the final performance metric from this value. By using these techniques, like k-fold, we can access model stability, and also it helps to improve ability to generalize to new data, because cross validation mainly used to assess the performance as well as the generalization ability of a model. So that we are using the technique k-fold, we can assess model performance, and also we can identify or improve the generalization ability for a new data set. So the main methodology behind the cross validation is to splitting the data set, and we have to train the k minus 1 fold or a subsets in the first iteration, and the remaining fold will be go for a testing. So these process will be repeated up to k folds. After that, we will average all the values. From this, we can get the final result or performance metrics. So this is the concept behind cross validation. So cross validation is a statistical technique used to assess the main concept of cross validation is to assess the performance and generalization ability of a model. We have to assess the performance as well as the generalization ability of the model. So this is the main aim of the cross validation. For that, we are using the data partitioning concept. So first methodology applied in the cross validation is the data partitioning. We are going to take full data set and we have to divide the data set into multiple subsets or fold. Subsets will be known as fold. In this, so next one is the training and testing. Finally, from this testing result, we can calculate the performance metrics. So, and also we have discussed about what are the types. We have many types of class validation, but commonly used methodology of cross validation is k-fold cross validation, because this is a very important and easy to validate the data set. So, and also we have many times recall the concept behind in the cross validation. First one is the, can you tell me what are the methodology behind the cross validation? Anyone? Anyone? Anyone tell me what are the steps involved in cross validation? Okay. Can you tell me, dear professors? Can you hear me? What are the steps involved in k-fold cross validation? Okay, we will go for next. We will move for a perceptron. So perceptron is the simplest, very element type of ANN, that is artificial neural networks, and it is a binary classifier used in a machine learning and AI. So it was introduced by Rosenblatt in the year of 1958. So the basic concepts of perceptron is it takes several input features and produces a single output. So this is the main concept behind perceptron. Can you understand? It takes several input features and produces single output. So which is a binary classification. It is very important in a linear classifier. That means it tries to separate the data into two classes using linear decision boundary. So mainly it can be used in the field of supervised learning, and also it is the type of linear classifier used primarily for binary classification task. Here we are going to take a data set as two classes. So mainly it is implemented in a binary classification task. So we can say it is a type of a linear classifier, and also it is another type of neural networks. The perceptron is a more complex neural network model, and it serve as a building block for a deep learning. So what are the components for a components used in a perceptron? That is inputs, that is that we can call it as the features, and the weight and bias, then activation functions. So these are the important components used in the perceptron. So the main model structure of the perceptron is a input layer. First one is the input layer, and we have a set of weights and a bias term and the activation function. So these are the model structure or components of a perceptron. So first one is the input layer. So these are the features of a data. It may be represented as a vector. So we can call it input layer as a features. So it will be represented as a vector. Here each input has an associated weight, which is used to determine the importance of feature in the final decision. Next one is the weight. Here the weight, each input has a corresponding weight. Yes, each and every input having a corresponding weight that is adjusted during the time of training. The weight represents the importance of strength of the input in predicting the output. Next one is the next term is the bias. Here the bias is an additional parameter that allows the model to adjust the decision boundary. So the term bias is mainly used to adjust the boundary of the model. It helps to shift the decision boundary up and down. So it provide more flexibility in a classification. Next one is the activation function. So the perceptron uses on activation function to determine the output based on the weighted sum of the input. So it is mainly used to calculate the weighted sum of input. In case of the perceptron, a step function that outputs a step function. So this is the important concept used in the activation function. So that step function, that one class label, we can consider one class label if the weighted sum is above a certain threshold, and another class label maybe if the weighted sum is greater than or equal to threshold, the output is 1. If the weighted sum is less than the threshold, the output will be 0. So we can call it as a class B. So these are the components or a structure which will be used in the perceptron. So this model works by taking an input data and processing this data through the input layer or using some components, and finally it will produce an output. So these are the methodology used in perceptron. So you can consider this example. So this is the input layer. We will take the input layer as x1, x2 up to xm, and the weight will be W0, W1, W2. So this will be applied through summation to get the output. So input function, so the input value with the weight will be goes into the input function. So after that it will go to the activation function to produce the final output. So already we discussed that the perceptron takes in a set of input features named as x1, x2, and the input feature, the weight of the input feature is denoted as W1, W2 to signify the importance of each feature in making a prediction. So in this input layer, the input features and the weight of each input will be going to participate. So next one is the weight sum. The perceptron computes the weighted sum of inputs with the weighted sum of the inputs plus the bias term. So we can denote the weighted sum as Z. So the Z will be calculated like this. That is the weighted sum of the input. We can use this formula for calculating the weighted sum. That is W1 into X1 plus W2 into X2. Finally, the result will be added to bias term. Here, the weight is associated with the input and B is the bias. Already we have used these terms. So it is which allows the model to take predictions even when all the input values are 0. If the because all input values may be a 0, we can take the prediction because these values finally will be added to bias term. So by using this term, we can make prediction. So next one is the activation function. So activation function already we have discussed here. If the weighted sum is greater than weighted sum, that means here the weighted sum is greater than 1 or equal to threshold, the output is 1, that is class A. And also if the weighted sum is less than 0, then the threshold, the output is 0. So this is the activation function. So the activation function is typically a step function. The activation function is also known as the step function or also called threshold function. All names will be suitable for activation function or step function or threshold function. So the output of the activation function either will be 0 or 1. Can you understand? If the weighted sum greater than or equal to 0, the output of the activation function is 1. If less than 0 means weighted sum is less than 0, the output of function is 0. So finally, we have concluded the perceptron mainly used for binary classification, and also it makes the binary decision. If the weighted sum of the input is above the threshold, the output is 1. Otherwise, the output is 0. That is negative class. Positive class are also known as a class A. The negative class are also known as class B. So we can discuss, we will see the limitations of perceptron. It is a linear separable data. The perceptron can only correctly classify the data. It is mainly used to correctly classify the data. That is a linearly separable. This means there must exist a straight line that can separate the two classes. So class A and class B, to classify or to distinguish the class A and the class B, we should draw a straight line. So that is the linearly separable. If the data, so class A denotes the output, the value of the output 1. The class B denotes the value of the output is 0. If the data is not linearly separable, the perceptron will fail to converge and no solution can be found. So that it is a linearly separable data means a boundary, a diagonal line should be present between the class A and the class B. That means that to differentiate the output of weighted sum, we should have the diagonal line between the classes. So that is the point discussed here. There must exist a straight line that can separate the two classes. So only we can identify the perceptron. Otherwise, the perceptron does not give any solution. Next one is it have a single layer, because the perceptron is a single layer neural network. It has no hidden layers, and also which limits its ability to model complex non-linear relationship in the data. Next limitation is no probabilistic output. The perceptron outputs a binary decision. That means the output may be a 0 or 1. For example, I can't tell you how likely a point is to belong to class 1, unlike a model such as a logistic regression. Finally, we can conclude that the perceptron is one of the fundamental algorithms in machine learning. Finally, we can conclude that the perceptron is one of the foundational algorithms in machine learning, and also it is a basic linear classifier that uses weights and a bias to make the predictions, so that we can learn a simple algorithm that adjusts the weight based on error on its predictions. So we can adjust the weight within the boundary for the input features. From this, we can predict the values. While it works well for a linearly separable problems, more advanced techniques like multi-layer perceptron may be used to more complex tasks. So in this, we are taking simple input, so that we are using single input layer with the weighted sum, with the weights to calculate the weighted sum. And also it provides an excellent starting point for understanding how linear classifier works and how machine learning models can learn by adjusting weights based on errors. So these are the important things behind in the perceptron. That means it is a basic linear classifier that uses weight. Here already we have seen that here we are mainly we have to focus the components of input features. Perceptron we have to recall now what is a perceptron. It is a type of neural networks, and also it is a type of linear classifier used for binary classification task. And also what are the components model or components or a structure of the perceptron means input layer and the weight bias term. By using the bias term, we can calculate the weighted sum. From that, we can identify the activation function. So these are the main components of the perceptron. So input layers will be denoted as x1, x2, and the input feature of the weight of the input feature will be denoted as w1, w2. From that, we can calculate the weighted sum. It will be denoted as z. The weighted sum will be calculated as the input multiplication of input and weight sum. After adding these things, we can add the bias term with this. So these are the important terms, components used in the perceptron. So activation function. So activation function is also known as the threshold function or a step function. Here the activation function, output of the activation function may be a 1 or 0 based on the value. Then limitations of the perceptrons is also very, very important. Next one is the neural network. A neural network is a machine learning program or a machine learning program model that make decision in a manner similar to the human brain. So the neural network will act like a human brain. How we have a structure in our brain, the same structure will be followed in the neural network. It uses mechanism that replicate how biological neural networks work together to recognize patterns, evaluate options, and make conclusions. So in this neural network, it consists of more number of layers of nodes, like an first one is the input layer, second one is the one or more hidden layers, and finally we will get the output layer. In a perceptron, we have an input layer, input features or input layer. After that, we can split the weights. After combine the weights, we will get a weighted sum. Finally, it will go to the activation function. After processing the values in the activation function, from these values, we will get the output. So the output of the activation function will be 0 or 1. But in neural network, we have only 3 layers. First is the input layer, and the next one is the hidden layer. Second one is the hidden layers. Third one is the output layers. Here, the each node connects to the associated weight of the threshold. So the neural networks is a computational model inspired by the biological neural networks process the information. Here, the input process the information, and also we have seen the structure or the layers of the neural networks. The input layer. So this is the first layer where the input data or features is fed into the networks. So each node or a neuron. So here the nodes. So this circle will be noted as nodes. Here the node or neurons organized into layers. So neural in this layer, the node of this first layer represents one feature from the data set. Here we have a 4 nodes, means here each and every node represent one feature. Here first node will represent one feature, second node will represent another feature. So each and every node in the input layer represents different features. Next one is the hidden layer. So after the input will be sent into the input layer. So the output of the input layer will be sent to the hidden layers. So what will happen in the hidden layer means this is the intermediate layer between the input layers and the output layer. A neural network can have one or more hidden layers. This is not mandatory. Each neural network should have a one hidden layer. It may have one or more hidden layers. So finally, we have an output layer. If the output of any individual node is above the specified threshold value, the node is activated, sending data to the next layer of the network. Otherwise, no data is passed along to the next layer of the network. So here, the hidden layer is the intermediate layer between the input layer and the output layer, so that the processed data in the hidden layer will be sent to the output layer. Each hidden layer consists of the neurons that transform the input into some useful form, and it will be sent to the next layer. Here, the neurons apply a weighted sum of their inputs followed by the activation function to introduce a non-linearity into the model, allowing to learn from the complex pattern. Next one is the output layer. The final layer is the output layer, where the network's output is generated. For classification problem, this layer might consist of one or more neurons that represents the class label. So we have to remind in our mind, that is the layers used in the neural networks are input layer, hidden layers, and the output layer. So how does neural networks works? Here, consider a neural network for email classification. The input layer takes features like email content, sender information, and a subject. Here, the inputs, here each node will have a single feature. First node will have an email content, and the second node will have the sender information, and the third node will have the feature as a subject. So here, totally we have a number of nodes used will be 3. These inputs multiplied by adjusted weights pass through hidden layers. So the network, through training, learns to recognize patterns indicating whether email is spam or not. The output layer with a binary activation function predicts whether the email is spam. That means that the output value will be 1. That is, the email is spam. Otherwise, it is not spam. How it works? As the network alternatively refines its weights through the back propagation, it becomes adept at distinguishing between spam and the legitimate emails. So mainly the neural networks where it is used means email filtering. To filter the email, whether it is a spam or not, we can go for a neural network algorithm. So here we have to use back propagation activation function. So what are the key components used in the neural network means neurons. So neurons are, that will be known as the node, and is the weight and the biases. Next one is the activation function. Next one is the forward propagation, loss function, back propagation, gradient descent, and finally we have a loss calculation. So back propagation means this is the method used for training the network, where the error from the output is propagated back to the network to adjust the weights and the biases. Can you understand? Can you hear me, ma'am? Dear professors. Ma'am, can you hear me? Okay, ma'am. Okay, thank you, everyone. We will continue the remaining session 2 o'clock. Thank you all. Thank you, everyone.
Gomati ma'am.